Alright, now, when you're working through here, it says state if the polygons are similar. Now, for number one, what type of shapes do we have here? Well, all the angles are 90 degrees, but are all the sides the same? No. So, but it has two sides that are congruent and then two other sides that are congruent. So what kind of shape is that? Starts like with an R. Rectangle. So these are rectangles. Now, if we want to state if the polygons are similar or not, what we need to do is we need to set up the proportion. Now, the nice thing about, remember, math is all logic. Math is all based off of this idea that things should be done the exact same way that you think that they should be done. Now, if I'm going to take 10, I'm going to take this side from here. What's the corresponding side to this side right here in the other shape? Is it the 21 or is it the 15? Alright, I agree with you. It's the 15. Why is it the 15 and not the 21? It's kind of the same side and they're orientated the same. That's one way of looking at it. That's 100% correct. But another reason, not the smaller angle, but the smaller side. 10 is the smallest side in the 10 by 14 triangle, right? 15 is the smallest side in the 15 by 21. So just like in triangles where the small side should go with the small side and the medium side should go with the medium side and the large side should go with the large side, when you're dealing with rectangles and such, or any other shape, small should go with small, the next one should go with the next one. It should line up nice and straightforward like that. So 10, if we're setting up our proportion, we get the 10 from the first one, so we get 15 from here, and that should be equal to 14 over 21. Now, a quick way to do this, like I said, an absolutely quick way to do this is just to do the cross product. And I'm going to attempt it with the phone. Remember, master's degree, so I can use my phone. I know it's horrible, but I can do that. Alright, you go 10 divided by 15. When you see 0.6 repeating all the time, what do you know that is going to be? What fraction should that be? I'll give you a hint, it's 2 over something. 2 over 3. So 6 repeated is 2 over 3. Now, if these are similar, what should I get when I divide 14 by 21? I should get that exact same number. Did I get that exact same number? Yep. Actually, it's 0.6 repeated. Oh, that was horrible. I'm sorry. So, are they similar? Yeah, they are similar. Another thing that you could have done is you could have said, alright, well, since they are similar, I could have done a cross product, got 10 times 21 is 210. 15 times 14, what do you think that's going to be equal to? 210. So if you do a cross product, that's 10 times 21, that's 14 times 15. You end up with 210 equals 210. Or you could take 10 over 15 and say this is equal to 5 times 2 over 5 times 3. The 5's divide out. This is 2/3. 14 over 21 is equal to 7 times 2 over 7 times 3. That's 2/3. Is 2/3 equal to 2/3? Absolutely. So you could have set that up. That would have been perfect. 100% perfect. So you could do the cross product, get the answer. You can just do the math, 10 divided by 15, see what that is. That should be equal to 14 over 21. Or you can do this. If you're in a non-calculator type of situation, 10 divided by 15 might be a little bit more difficult for you because you have to do some long division and you might not want to do that. So you might want to look at reducing fractions or just doing a quick cross product, because the cross product should be equal to each other. Now, I want to show you a trapezoid here. Number 5. If I take 8, what's the side that's going to correspond to 8? Okay, 10. Now, I'm going to take this one, 14 over 21, because that would be 14. And just make sure that if I used an 8 in the top, in the numerator here, I'm going to use a 14 in the other numerator, and then that's corresponding side is 21. Now let's reduce these. Well, actually, let's not reduce these because we have decimals. If we have decimals, then we have to do some multiplication. So I'm just going to do the cross product. What's 10 times 14? So 10 times 14 is 140. Then 21 times 8 is 168. Everybody believe me on that one? Now, the question is, are these equal? No. So, are these similar? No. And that's the key, is if you find out that one proportion that you set up doesn't work, it's one of those things where as soon as one thing fails, the whole thing is not similar. It's kind of like trying to prove something. If you find out, or in an experiment, you think something's going to happen, if one thing fails, then the whole thing's going to fail because it's not going to work. Then you have to go back to the drawing board. In this case, they're not similar to each other. They're both isosceles trapezoids because that side's congruent to that side, this side's congruent to this side. All the angles are the same, but the sides are not in the same proportion. So it doesn't mean. Now remember, try not to get into your head this idea that just because they're not similar doesn't mean that there's some negative connotation to it, or that the shapes are bad or anything like that. That's not the case at all. It's just they're not similar. It's just like people. Some people are not similar to each other. Like, for example, Danielle, correct? I'm not similar to Danielle. She's a girl, I'm a guy. That ruins it right there. But that doesn't mean anything at all. It just means that we're not the same. We're not similar. That's all it means. It doesn't mean anything else whatsoever. And with this, it doesn't mean anything else whatsoever. We can still examine these shapes. We can still figure out the areas. We can still do all the things that we want to do with it. It's just they're not similar. So don't think that if they're similar, they're bad. Because I know a lot of us, as soon as we find out that there's no solution, we think we get this whole negative picture of what's going on in our head. That's not the case at all. So work on this today actually, for the rest of the hour. Because you got till 14, so you got 13 minutes. You could probably knock out the majority of it. If you need to borrow a calculator, just go back there, grab one. You don't have a number yet, but you will